Hi, and welcome to this video on finding the length of the curve. And to do this, we're going to use calculus. You should have already watched the video that gives the explanation for where the formula comes from. So let's quickly look at the formula we're going to use. Since this function is in terms of x, we are going to use the formula that finds the length for curves defined in terms of x. So we're going to go from a to b, where a and b are where your interval starts on the x-axis and ends on the x-axis. We're going to use the square root of 1 plus our derivative with respect to y, dy dx, quantity squared dx. And remember, this comes from the Pythagorean theorem. So when you're doing these problems, the first thing you want to do is find the derivative dy dx. And in this case, this function looks pretty nasty, but when you take the derivative, it actually comes out a little bit nicer. So let's go ahead and do that. And when we simplify this, we get something that looks like this. And now we're going to take this as our derivative, and we're going to put it into our formula here. So remember to square it. Don't forget that piece. So our length is going to end up being the integral from, and we're going to go from 0 to 1. So our lower limit is 0, upper limit is 1. Square root of 1 plus the derivative squared. And at this point, you have everything set up. You can use your calculator to evaluate this. And if you don't have a calculator, this you would want to simplify the radicand, and then you would use substitution. This is a simple substitution problem. So this one you can definitely do without a calculator. However, I'm going to use my calculator. I'm going to put this into my TI 83 or 89 or whatever you've got, and you end up with 1.69672. Remember, if you are taking the AP test, you need to truncate or round to 3 decimal places. So you could leave your answer as 1.696 or 1.697. Either one of these would be acceptable. So that's the length of the curve of this function on the interval from 0 to 1. If you want to look at a graph to see what that actually means, that would be a good idea as well. All right, let's go ahead and do another example.